Hello, my name is Cesar Monson. I'm a student for Science and Technology, and today I'm gonna talk about global circulations, capillary wave, and breaking wave. To understand the global circulation, first we need to see the global circulation is about the cool air of the land making a high pressure, and the warm air of the land is making a low pressure. So we can see in the picture here with the sun, so the cool air is going down and the warm air is going up. So this is affected by the Coriolis effect. It's affected by the wind directions. Now we're going to talk about the creation of the wind. So the sun hit the earth, hit in different directions, hitting the south polar, the north polar, hitting also in the line in the equator. So when creating the high pressure, low pressure, start pressure going up, low pressure going down, start creating the Halley cells. So the Halley cells is following by the Ferrous cells, the polar cells, and this is all is created by the movement of the air. The movement of the air is affected by the Coriolis effect. Could be is going to clockwise and clockwise. Now, to understanding a little bit more about the high pressure and low pressure, now we're gonna talk about the pressure charts. So this is so we see that this is the high pressure that we call it the limes. Is it called wave generated area, and this is here can we see the low pressure. So here is when the wind is start creating capillary wave. We'll start talking about the capillary wave. Well, understanding for the capillary wave, when the wind starts traveling close to the oceans, start getting like a turbulence in the water, it start making this kind of wave, like that very messy wave. This is called capillary wave. And then the wave is going to start traveling over the ocean, getting a gravity wave. And then all of them start getting together, it start becoming a wave grouping. So all of these actions is called fetch. Wind blowing over the oceans, generating wave. As I said, the wind is traveling. So here is how they travel and speed. When the waves start traveling, it makes in the water start getting a circulations, oscillations. It means like here the rounds that we see the circular oscillations. As we got here, we can see is the dip. The dip disappear. So when the wave is getting close to shore, it's like becoming shallow. As we go here, the ripples go up and down. So this is the moving back and forward. As we know, the deeper the water, the faster they travel. The shallower the water, the slower the travel. Here we'll talk about the breaking wave. So as we see here, we got a rip here. When the wave start breaking in the reef in the middle, start getting the concave reflections. So basically here it become the reef, become the headland, a very powerful, and then start making the plunging wave. And then this is the land. The wave hit here on the headland, that we call it like carbon reflections. and it's called we have a spilling wave, and they are less powerful. Here we go. I'm going to explain a little bit more the formula. As we go here, the circular solutions. In the circle go big, small, and if we go here in the deep if is it basically is not touching the sea bay, but is the half of the wave length. If we wanna get a deep, is the half the wave length, and then if we wanna get the shallow, so it's the 1/20th of the length of the wave. Basically, it's no much going on here. It's only the we were talking before with the ripples. This is the land. If we want to get the intermediate, the formula basically is the depth. If the depth is between the half of the wavelength and the 1/20th of the shallow, this is the intermediate. Now I'm gonna talk about the types of wave or breaking wave. So we have the spilling wave, we have the plunging wave, the surging wave, and collapsing wave. Here the spilling wave is gently bottom slope. We can see the wave. In a modern plunging wave, the land is more moderate for the bottom slope, and the steep in the surging wave, the steep bottom slope. So basically everything change or depends of the everything depends of the sea, how it looks. So that's gonna make the change of the type of the wave. Then hi, so in conclusion, I wanna give you a quick recap about global circulation, the capillary wave, and the type of break on the wave. So we go here, it hits the sun. So we know the sun hitting the earth and hitting different areas. So we know here we have the equator. We go here the north polar, and down here the south polar. So because when the sun hits the land, hits in different air. So cold air go down and warm air go up. So basically it makes it like that. See, and that's it called this is called the Hartley cells. So we call the Hartley cells, as I said the first time, and this is followed by the ferrule cells and the polar cells. Exactly the same. Going up, go down, exactly the same. So because all of this is created by the movement of the air, the movement of the air is affected by the Coriolis effect. So the movement of the air could be anti-clockwise and clockwise, and all of this is called, as we say, the Coriolis effect. Coriolis effect. Because of the moving of the Coriolis effect, we start creating the low pressure and the high pressure. So we go here the high pressure, we go here the low pressure. So the low pressure is making the generation of the wave. So here is a wave generating. So the wind blow on the sea. Let's imagine this is the sea. Start creating turbulence, because this is the wind, into the sea. So the turbulence start making capillary wave. So this capillary wave start traveling. And start traveling, it then called traveling wave, and then we can gravity wave, and then start getting the grouping wave. Grouping wave. So that when they start all getting together is when they start getting close to the land. In everything that change when is the shape of the land. Like I said before, if we got here a wave, the wave is gonna break here, and it's gonna make different powerful wave over here. It's just that hitting the headland, wave gonna hit here first, and it's gonna change the shape of the wave. It won't be that powerful. So this is basically a quick explanation how the wave it will end up in the shore. Hope you understand. I want to say thank you very much for watching my video, and I believe this is going to be a really good time. Thank you very much, and